Okay. Hello, everyone. I can't hear you yet. I will try to fix that. Am I late? Yeah, 1 minute. Not on Twitch. Twitch was right on time. I can't hear you. Is it connected to? Weird. Wait, is it muted? No. No, I can hear everything. Okay. Let me fix the chat. A typical bitluni stream. Fixing tech first. Here. Say something. Say something. What was the text of the song? Now I can hear you. Well. Hello everyone. How are you doing? So, it's Kaspar's fault that I'm late because I had to get some ginger tea. Oh, the color looks odd on camera. Yeah, it's probably some people wouldn't call it tea because it's just ginger scraps. Then we have today for camera not working yet. Let me fix that. Now this is thermal camera. Is it still? Huh? Okay. Okay. Yeah, here we go. Yeah, we have some mini pizzas for food. Look dry. They are already cold, but Tony made them. And there is pineapple. Pineapple belongs on pizza. So we have that's the food of the evening. Yeah. All right, what did I miss? Okay, hello Kaspar, hello Dutch, hello Johnny, and that's basically it. People are enjoying the good weather outside, are they? Or do they think there is no stream today because we are sticking to UTC, and that basically means there is nothing. We moved by an hour in Central Europe here, so at least that's that. Right, let me fix that here. All right. What did you went 3 eventually? All right. What's the topic of the day? I would say let's finish the power board. Oh, what? It was announced. I announced the stream at 12 o'clock noon today, so the people will know that it's starting at 8. Central European summer time. Oh no. Yeah, let's do the powerboard today. Let's finish that. I have a lot of news. The Friday stream I took offline because alright, okay. Oh yeah, you're the first one who got me today. Kaspar, you're the first one who got me, but I was wondering, there was nothing in the chat. Yeah, Johnny's live integration that we are using to basically update our stream ID to the TTS system. It's still a little bit janky, my TTS system. All right, this is what I want to finish today and order. Oh, there is good news. You want to know the good news? Let not dox me, but I will show you the good news. Wait. Okay. Here. Somewhat good news, somewhat bad news, because bad news is I won't be receiving the blade PCBs, the cluster PCBs until Easter. So DHL already announced it for Tuesday because we have public holidays on Friday. Then DHL Express doesn't come on Saturday because they do businesses, I believe, only. And then so Saturday would be an opportunity because it's not a public holiday. And then there is public holiday on Monday, and on Tuesday I finally get, hey Brian, a rare sight. It's the time better for you now. The kids are in bed, and you can join. Tell us about your solution, your Wi-Fi solution for the water heating system. So it's basically like an Wi-Fi thingy that triggers a switch. Kids are karate. Oh wow. Okay. Yeah, I have to be careful. Next time, Saif will break my nose once I threw a snowball at her. So basically, I will receive the boards next Tuesday. Son of mini controlling 20 amp contactor connected to. Okay, yeah, 20 amps should be plenty enough here. I'm switching like the whole heating system, which is a maximum of 63 amps here. That's why there is like the biggest switch you can get is Kelly. Oh, yeah, I mean, it's quite some time passed since we met, so she probably grew like another foot or something, and gained some actual weight that she can utilize to break bones. All right. I mean, Saif even got her revenge with the chicken. The chicken, she basically set up for the people in chat. So what I did, the Brian is from Ireland, and he got two kids, two girls, and they visited us. And what was happening is they were basically, we had snow here, and there's rarely snow in Ireland. So we played in the snow like basic, like a typical Central European person would do. That means also throwing snowballs or at each other or putting snow water in other people's faces or whatever. I wasn't cruel, but I threw a snowball. What was it? I can't remember even. So basically, yeah, the girls were a little bit caught off guard. That's the snowball wasn't like an icy snowball, like very hard or whatever. It was just snow, but they were like really surprised by being thrown snowballs in the face, and then no snowball was. You know what? I have I think it might be this one here. I have a scar because a friend in Poland. So maybe that's a Polish thing. Caspar, did you mention it? So when I still lived in Poland, and I was a kid, I had a friend, and the friend was quite a little bit rough, like on the rough edge, and we were throwing snowballs at each other, and he basically took a stone, put inside a snowball, and he hit me right above my eye, and it was like bleeding, and so now this is how you don't throw snowballs, kids. I had like only a non-icy okay, your 3-year-old daughter in the face just about. Come on, don't blame Poland for everything. This is my. This is for Kaspar. Kaspar, this only happened to me in Poland. So being. No, it was the friend, the specific friend. He was like very troublesome, rough childhood. That's why I understand that he got the idea you could win snowball wars with stones. Has nothing to do with Poland. I got like in fights in Germany all the time. Anyways, yeah. So the story goes on. The kids were really surprised. There. I think there might have been tears involved. And what happened after Brian and the kids and Caroline left, the kids started to plot a revenge plan for me. They wanted to get back on to me like with something mean. And when I visited Brian again, they have chickens. And what happened is Saif, which is the bigger daughter, planned like a trap where I try to take an egg from. Was it an egg? Yes, from one of the chickens. What's the name of the chicken? It's probably doesn't live anymore. Oh, oh, that what Kelly says right now. Oh! I'm so sorry, Kelly. Now you know what you have to do. You have to pass on this. You have to pass on to the next generation. How you. This happens in a good old Berlin as well. Snow. We're throwing stones at each other. Okay, yeah, more and more. Hello, by the way. Welcome. Wavy was the chicken. Yeah. And you know what happens if you try to to take an egg from a. Oh yeah. Did you eat her? Might be another cruel thing to ask. I don't know if the kids are listening. Yeah, but it depends what you do after that. Okay, so if the kids were listening, you could just say, "No, we didn't eat the chicken." Yeah, what happened is basically the chicken attacked me, picked my hand, and then we were good. I believe we are good. But Kelly still needs a revenge. I guess at some point she will just let me trip or something with what was the move from Karate Kid? In German it's Fußfeger. I don't know how it's. We as kids we were completely in the 90s. We were obsessed with Karate Kid because that was like the time that it came out. And crane kick, yeah. And all the kids were basically practicing the karate moves from crane kick. No, not the crane kick. The crane kick was like the finishing move. Like the Fußfeger is the one that you. Foot sweep, yeah. A foot sweep. So it's a basic, yeah, here she will just do this sweep my leg when we are like I don't know, hiking at some mountain or something. Yeah, that what will happen. Anyway, story time over. Let's get back to our crazy project. So boards are finished after. Oh yeah, story. I was upset with JCPCB, I must say, because I ordered these boards like 3 weeks ago almost. Was it 3 weeks? 2 weeks ago, and they were stuck again and again. And you know what happened? They I contacted the support here on the site. You can contact the support and ask why are they stuck. I ordered them like I don't know. Production should be like 5 days, and it was 10 days. Isla, ask Jordi about that. I don't know if Isla is. Sometimes they have also issues, and they told me that the boards were damaged during the process and they have to remake them. So they were like that's why it was delayed, and they just didn't communicate that to me. It was stuck at I don't know final check or something in the progress bar. If you yeah, we can check that. Okay, um, it was basically stuck. I think final inspection or something. Yeah, here it was stuck like for 3 days, and they managed to do is like to remanufacture it within 3 days. Prusa fanboy. And then they did also a rush job on here. Uh, Assembly was basically done within 1 day. So that now it's waiting like it's somewhere in China trying to get to me. There is more news, or more news. I mean that's story time number one. Story time number two is okay. Who missed the Friday stream? I did some tests with the FPGAs and with the connectors, which is really weird. So the main board will have the Tang Prima 25K because of the form factor, and there is a weird thing going on because that's like a 60 pin connector there. These tiny board to board interconnects. But they have 62 pins. It's really weird. Was it 62 or 64 even? I don't know. No, 62 or 64. Like there are extra pins and they are not documented anywhere. Even like the 3D models don't show it properly. Let me. Oh yeah, I can show you even. I made already a board for that, so that short update will be. Yeah. Oh yeah. I need to finish that as well, so I can do some tests. But I think yeah, we need to get that done. Okay. Here. Where is it? That's all right. Yeah, I have all the models, but then if you look closely, there are like extra pins. It's so weird, but that seems to be shielding because the pins aren't in this inside of the connector, and I checked that on microscope and everything. It's really confusing sometimes. Mega super yes, Basil. That's I will try to get some on the major on the big one. Wait, let me show you. Where is it? Do I have it? Blade base here, because we have a lot of incoming. The blades they have like a 60-bit interface. Wait, what on the tank nano 25? No, it's balanced. The count of G and D is basically has to be the same count as the power pins. All right, so this abomination, this UFO. Okay, so yeah, this is for the people who missed the last streams. This is basically the base with some power stuff, and we have like for each of the connectors we have like a 16-bit bus incoming, also an SPI, and I determined like I want to place some 10 nano 25 to basically digest all the data, but I'm not sure of the final stuff. I also bought like 150 serial SATA cables and connectors. We have some pin connectors coming from LCSC. So this board is basically it's exchangeable because we only need it once. I don't need like to manufacture. It's not very expensive. The connectors here, that's basic PCI Express times 4. And you can see there's 128 connectors, and this is where each of these connectors will receive one of those blades here, which has 512 MCUs plus 17 MCUs with FPU. So this is I don't want a bottleneck here. We will have a bottleneck here in data bandwidth, but I want to keep it as high as possible, like as wide as possible, the bottleneck. It's so expensive. This project I listed all the expenses since it's open source anyways in the end. These are the expenses for the materials so far, and I must say, sorry. Do you see the total that I spent so far? That's the total. Almost 4,000 euros. That's euros. That's like $5,000 already spent only for the parts. And we still need to spend another 6K. That's calculated here. 6K for the CH570s. And another 1.6K on the CH303. Yes. You know what? The mini digger, that's another news that I got. Where is it? So the last piece of where is it? Damn. So I have a 10% coupon that. Yeah, we can do that. So I received from my hardware store. I received a coupon for 10%, which Holy Flame, they donated already 10,000 MCUs. So I will ask Patrick if he will give me a better price, but I really don't want like to get like all of them for free. Hey Terran. So yeah, I got a coupon. What's the hardware store? Tom Baumarkt sent me a 10% coupon. I don't know where it is. It must be somewhere here, but it's such a mess here in my room. Or I took it downstairs. So another story time. Digger. It costs like basically in Germany they cost all 5k. The diggers, the mini diggers. And I was waiting for an opportunity to get a discount. And I got a 10% off coupon, which is 500 bucks on the mini digger. It's the mini digger is currently not available. Like you can get it in some hardware stores around Germany because they are quite popular, as it seems. And the coupon expires next week or something, end of next week. So I called the hardware store and asked them, all right, can I buy that in Rödelheim, Frankfurt, and let it ship to me? And they told me, oh yeah, that's quite far. How about, oh yeah, it's not available at your location, which would be Bebra here close by. So I will contact market Facebook. Yeah, I'm not Facebook, man. All right, you can check Facebook and then tell me. Anyways, he told me I will call Zipper, which is the manufacturer of the mini diggers that they are selling. They are from Austria. He called Zipper. When the next scheduled delivery would be to the hardware store that is close here, and he told me it's end of April. They will receive some diggers, and he would extend my coupon for it to be still valid until that time, so I could buy the digger this month. Unfortunately, I'm still short on my budget. We have like 2.7k, I think, in the mini digger, and I don't really want to overdraft my account by 2,000 euros or something, because that last part of that mini digger should have been paid by this project here, which is unfortunately still not finished. And since we are so far deep in our expenses already, there is like I have no clue what the outcome is. I might even like dig into my own like margin to be able to finish this project. So as long as I didn't order like the blades and everything, I can't commit to the digger yet. So as soon as I know, all right, there will be, at the end of this project, there will be some payment for me. Like I will get a paycheck. I don't have to pay extra from my pocket to finish it. Yeah, Kaspar, I feel you, but I mean, I just wanted to work such that we proved our like that's possible, and then from that point we can extend it. So right now, as it looks like, the liquid cooling is off the table for this budget. That would be another 2k in expenses for the coolant, the cool stuff, like the tube is 400 alone. Joint account with from your joint account. No, Tony already offered to lend me the money, but I really don't want to be in that situation. I think there will be next week when we receive the blades. I will be able to order the MCUs, to order the PCBs, to basically do everything that's still needed to finish this project and see what's the outcome. If we are still within budget for this project, I will be able to commit to the digger this month. If not, I will sleep in the mini digger, yeah. If not, I will call the guy from the hardware store and ask him to just extend it for another month, and then we will do like an ad for JC again or whatever. I don't know. That's the state, but there will, it's a surprise that the mini diggers, that this opportunity came by. Also, I think Norma offers another mini digger, and it's another type, which is also quite cheap without a coupon. So we can check the prices right now, because I feel like it might be the year of mini diggers, and we are prepared at least a little bit with the excavator fund, just to get the last bit. I need to finish a project. Let me check. I didn't try. Did I drink my tea already? Oh yeah. Yeah, ginger. I like mint the most. Peppermint. Okay, bugger. What? Okay, let's see. Look at that. You can get Shepach for 4679, yeah. That's like 170 more. Free shipping. Oh, that's refurbished. Okay, so basically that's a used one. Which is alright, I would guess. eBay. Kubota, yeah, I don't believe that. It's gone? No, what is it? Yeah, no. Huh? Mini bugger. Yeah, where is the mini bugger? Here. Shepach. Gebraucht. Yeah, it's used. 170. Yeah, so, I mean, for a similar price we can get a used one or whatever, but I believe I could talk to the hardware store guy and get an extension for that coupon for like another month. So we just need to make sure that we finish this month our project. What's the prices? But I saw one, I think, here. Guide size. Oh yeah, it's also with the roof. The one that I saw. Why doesn't it open? It doesn't open. Guides are alls. Okay, here we go. 4740. Yeah, that's the price. Norma, yeah. Page blocked. Was there like a tracking? Yeah, that's the current. You can see that. the price for this one without the roof. Oh yeah, April Fools. Oh no, I didn't fool you. Anyways, I can show you what I received today. Oh yeah, by the way, I calculated we spent on cables, power and everything $1,050 alone. This is like ATX. It was a huge mistake to try to work with ATX cables. Whoever mentioned I should just cut them off and use XT60 or whatever right away was absolutely right. It's such a confusion with the 6-pin and 8-pin connectors, ATX 6-pin and 8-pin connectors. Like I paid for ATX cables. Okay, that's 50. Another 16. Wait, there is, I think, that's 104. It should be something more. Yeah, and then connectors, PCI times, no wait, it's connectors, wait, ATX connectors and more Molex connectors. Yeah, that's $117 just for some cables. If you look at this board, you can see we have connectors for 4 of the boards are powered by one XT60 connector. Custom cables now. How do you do that? Is there like, I mean, custom, you can just arrange, let them assemble them or what? To let them arrange them like a harness? I should have done that. I mean, lesson learned. Here is what I received so far. That's 30. All right. Okay, let's take a look. That's okay. This was a welcome deal. $1. All right. And then we have 30 centimeters. They don't look like 30, but they are. 12 gauge wire. You need to be really careful buying like off AliExpress rubberized silicone. So quite. And 12 gauge XT60 like that, 30 centimeters, and this will be, then we have of course the connectors. Yeah. In what way? Because if you order XT60 connectors, XT60 cables, you will get a 16 gauge wire which isn't capable of carrying like 20 amps or anything. So like there like to have, I think I took 12 gauge to be comfortably carrying 20 amps. Yeah. So for 20 amps, I took a 12 gauge to be on the safe side. Otherwise, you get like incandescent light bulb in the end if you have like 16 gauge wires there. Or sometimes, I think 16 gauge was like a typical XT60 extension that I saw. Need to really be careful checking it. This one is more stiff, but they are also connected like that. All right, so this is like 30 of those, 31, and then 50 connectors, male and female. I like to use, or you should use probably this on the power side, like, and this is the supply side, and the one with the pin is the consumer side, because this here you can short the pins if you drop a wagon loads. You say we should put multiple. Okay, this PCB doesn't have space to comfortably put like another PCI Express or whatever connector there, because we need some logic and data lines. But if you look closer at this board, what do you see? So you are absolutely right with that. Here is the power board. We have Molex, a 8-pin connector, which also takes the 6-pin connector here, and XT60, and so we can decide whatever as input, whatever we like. And there is the DC to DC converter, and this is 2 times output. Yeah, 12 gauge. The power input jacks. Yeah, power input here. Confusion. Very expensive. I tell you what's expensive. We get, I need in the end, I have 40 of those here. And each of those will take like, they are capable of supplying 30 amps at 3.3 volts, which is 120 watts. So what I want to do is I want to take one of those here, ATX, the 8-pin ATX connection supplies up to 150 watts, and I want to, the typical one is like a splitter cable, which has 2 6-pin or like this odd, wasn't able to find this exact connector, because that has like this extra, why is it so dark? Give it more, wait, maybe I can add more brightness. Huh? Yeah, alright. Yeah, you can see there is like a connection between those 2 pins if you, like the plastic continues in between. So this is not compatible like with the typical 8-pin connector. This is more like the 6-pin. I also ordered the connectors for the 6-pin, which is enough for supplying the 75 watts that I would, or in my case, what was it per board? I want 20 amps times 3.3 is 66 watts. Yeah, this is interesting, because I mean, what you suggested is have like different connectors there for power and XT60, and what I went with, and the issue that I had, like trying to stick to ATX whatever, in the end turned out to be more complicated than converting directly from like making a cable that directly goes to XT60. I have now the boards designed with both options. I can use the ATX power input. Single ray, I believe. Yes. Or is it? What does that mean? Yeah. I think it's single. So, the costly thing, I will be able to use this here from 8 to 2 times 6. No, I'm not. Because the power supply... So, the power supply is only capable of doing 3000 watts in 12 volts. And I need 2400 watts in 3.3 volts. Sorry for not mentioning that. This is where this comes in, and this was also a big part of the cost. And these things here, these are DC to DC converters, which are capable of doing 12 to 3.3 volts, 30 amps, and 95% efficiency, more or less. 94, 95. So I don't want 12 volts near my PCBs. So I will arrange 32 of these here plus some extra. So in the end it will be 40 of these boards around the perimeter, with cooling heat sinks and cooling fans stuck either on this side or on the other side. I'm not sure yet. I have the option to do both. That's why I'm trying to keep this area free from any pins, like through hole pins. So this is 5.5 centimeters hole distance, and I'll be able to basically put either the fan on this side or on the other side here, directly on the... Foo! Welcome! You missed all the fun so far. Thank you very much for the sticker. Which fund is this? Is this for the excavator? Yeah, let me put it in the excavator fund because we need some more cash in there. Wattage, or you mean current? The estimated current was 800 amps in total. We have measured. It's not estimated, it's even measured. We have like measurements on that. Power code. Oh. We have measured. Okay, I have calculated a total of 7 amps was calculated. 7 amps was calculated. Or no, wait. Here, 5.12 was calculated. 4.8 is what we measured. Amps per blade, and it's 128 blades. This is only the MCUs without the LEDs. So 4.8 times 128 blades. That's 600 amps. That's 600 amps on the just on the lowest level. This is insane. 600 amps. What? This is just the LEDs are marginable and they are quite bright. We have like 65,000 LEDs at 1 to 3 milliamps each. Sick. It's also a thing why I want to use. Oh yeah, there is one thing missing. I will put a potentiometer here to be able to adjust the voltage. If we can reduce the voltage more and more, we will have less, basically less heat and less wasted power. CPU heatsink on that one. We can check. Oh, I don't think I brought one with me from the basement. It would be a few. So I have the power supplies. They are quite pricey. So this little buck here is 14 euros, and I had to buy 40 of those. I think I have 41 in total now because I need one for testing. So look at that. That thing. Oh, it's really bright. Sorry. Wait. Okay. Yeah. So yeah, you can fit a few. The issue is I still don't know. There is no recommendation in the datasheet how to cool it. They say there is no mentioning. Yes. Hard to solder. I would reflow that. Nah, this is not. This is a piece of art. So, what will be happening in the end? I will have. So these boards, I will just place 40 of those arranged around the perimeter of this here. So there will be, imagine this is like that. We have the blades. They are standing upright here. Here is the blade. Oh, can we show that? That takes a while to load. It's a big model. Does it load? Yeah, especially with streaming. I changed to H.265 codec. Is it possible that silicon carbide rather than silicon is silicon carbide for which IC? Does it do anything? Oh yeah, it's loading. Silicon carbide for the regulator. What? I have no clue. I have no clue. You can read Murata datasheet here. This is the part number. Get that. Whoop. Oh no! Twitch is not streaming. Oh no. Oh no. Twitch doesn't support the codec. What? No. What's happening? Why is Twitch not streaming? I totally missed that. Is it No, it's not. Oh no. I just noticed that Sonic isn't here. Oh no. What do we do now? Do we restart the stream? What's the issue? I have no clue why it's offline. Shoot. Okay, you know what? The stream will hang for a second. YouTube is okay with that. I will try to change it back, but it's weird. Didn't we stream on last? Oh wait, it isn't the codec. We streamed on. How do we? Why isn't that working? Reconnecting. It doesn't like, okay. Twitch streaming settings. Now I'm sweating. Right away. Okay. Current per regulator 20 amps. I don't know what's happening here. Why isn't Twitch... Somehow this Twitch doesn't like... Okay. Stream will be back in a second. Sorry. Is it now working? Oh no, it was the encoder settings. I'm so sorry, Twitch people. No, is it? We are back. Yeah. H.264, not H.265. I'm so sorry, people on Twitch. Twitch didn't like the new encoder settings. That's why that didn't work. I had to revert my changes. Oh no. All right. Yeah, so let's silicon carbide. What? Is this like a special silicon IC? A new technology or something? I'm sorry. 94%? Yes. No. Darren. That's not true. You looked at the wrong thing. You looked at this here, huh? This is what you saw. Oh no, that's for... Yeah, and then look up here, then you will find that you are wrong. Terran, you are wrong. I'm right, you're wrong. V out 0.7 volts. Now you scroll down past 1.8, past 2.5. Here we go, 3.3 volts, 20 amps. Here we go. The 20 amps should be around about V in 12 volts. Here, 95. Is it? Gotcha. No, no worries. I was wrong myself with that data sheet. So it's quite confusing because you don't see the volt. Okay, it's right there. It says it's right here. But yeah, that's why they are so expensive. And I spent, according to my data to my expenses sheet, TMC and Mauser. Mauser I got like the last ones. Yeah, $480 just for this DC to DC converters. 41 pieces of these DC to DC converters. $481 to get from 12, like to get 800 amps from 12 volts to 3.3 volts. That sounds mad. 800 amps sounds mad. We can weld with this. Yes, we can weld. We can make a spot welder. Yeah, and they have some safety and everything, so built in, shutdown, over voltage, under voltage, whatever, which is quite good. Yeah, I didn't want to design the power supplies myself. That's why I went for these. And in the end, since I'm not soldering them on any janky project of mine, except if you count, oh yeah, it loaded. Can we? Oh, does it? Yeah. How do I rotate? Here. Okay, so yeah, there is no this. Okay, so imagine this is like, can I rotate it? How do? Okay, so they will be arranged around the perimeter down here, well, at the socket, like here, 40, 2 rows, a 20, everything is thought through. If you take 50 centimeters, okay, well, that's 500 millimeters, times pi, divided by 20, the width is basically 78 millimeters, 78.5 millimeters per board, spacing on the bottom. That's why these power boards are designed like these. They're only 6 centimeters across. That's only 60 millimeters, but they will be mounted around that perimeter, and they will have all those will have the cooling fans, which are, can I show you the cooling fans? Mounted 5 point, I measured even, oh yeah, here you can see my desperate try to get from the 12 volt high power connectors from the power supply to 4 times 8-pin connectors, which is actually to spec because we have 600 watts to 150 watts each, and from those another set of cables here this year that convert to from 8 pins to 6 pins each, and I can connect the 6 pins each to this here. That's why we end up from this power supply, which doesn't have 40 cables going out, actually having 40 cables going out. It's quite a lot of cables. It's like, I don't know, 1,000,000 cables. Crazy airflow. Now that you are talking about it, there, this whole contraption here, it will have quite a densely populated. As you can see, there is only 1 millimeter distance between the boards on the inner side. Oh yeah, they will wait. The boards, let me do it. Yeah, they will not. It won't fit on the donut, but I can maybe show it in Paint. No, not Paint.net. Paint. Yeah, it's quite a lot of. You wouldn't be able to even like each of the that's wasted 3.7 watts, but 3.7 watts if you have it enclosed in whatever is still a lot. I don't know if you experienced like 5 watts. No, shouldn't freeze. Why did it freeze? It's not me. Oh, sorry. I don't know what happened. It's not on my side. It at least doesn't look like that. Oh. Hey Sonic. So I noticed quite late that Twitch doesn't like the new encoder settings, so never change a running system. I I had to change back in midstream the settings to H264 again. So sorry that I'm late. And we started at 8, which is UTC still same time as usual. All right. Okay. So these will be the power boards, and we will have. Oh, you're watching some news from what is CST? What is that? No, 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 no. I'm not done, Terran Visitor. I'm not done. All right. So, um, the 5. I assume we can dissipate at least 5 watts from here with the heat sinks that are arriving quite soon. Let me copy that. Ah, shit. What? What's going on? Can you hear me? It's your... Not everything is my problem. Yeah. Yeah, Terran. Okay. Let me get that image. Ah. Okay. So we have these heat sinks coming. They will be on each of those boards. Here, here, here. Oh. I always ask, you know how you find out if it's a scam call? 99% of the scam calls are easily taken out by the question, who are you trying to reach? They know no names most of the times. They have no data, so they just know the number, and they will try to run down their script, and you just ask, who are you trying to reach? Who's the person you're trying to reach? So simple. All right, so the power supplies will be in 2 rows. We can maybe put it staggered like that, which will look cool. This way we will dissipate 5% of the heat that's produced during the DC to DC conversion here. But you remember the Amazon link that someone dropped? Look what arrived today. This item if we look at my list here, item 39, $32. Here it is. No, wrong. Here. This is the car radiator cooling fan. 12 volts. We can try it. I didn't try it yet. Yeah. And it is I think 47 centimeters or something. So it's basically almost the right size. Almost the size, and it will blow from the top. It's a big fan, yeah. It will blow from the top. This is our so it will be on the top here. We will have basically some legs here. Like I will put some. Where is it? Here. Like a long, very like maybe carbon, whatever standoffs, like tubes, and then put the fan on top of it. Like that, and it will blow wind like that, and I hope that's good enough. We will monitor, we will test it, we will find out. If not, we have like to put a duct here in the center to be able to like distribute it more evenly. Yeah, Colin Force. Yeah, we take his hover bike for that. That will be a fan that's good enough. We can try if we can run this fan from 12 volts of our mini power supply. True to the power boards. Oh no, the what? The base? What? No, the heat sinks are on the outside. Oh yeah, I will put it this way around. Wait, we can try. We can run it now. Let's try to find out. F around and find out. Cutting. Can we run it from this power supply? circular PCB. Yeah, there will be holes, but I believe this PCB. So I want to design it in a way that there will be only like a PC case. I mean, we will put maybe one of this not nocturnal, be quiet fans for the power supply. The power supply itself has also the own fan like that, which is this will be mounted like in a, I think in a box. We will see. It won't be completely open, but there is no heat generated inside of it except for the DC to DC power supplies, and I try to get the heat out through the boards. No, you know what? Central air heat exchange system. Do you mean for the main cooling? No. I don't know. We will see if it works or not. Let's try to try. Let's try to see if that fan. I mean, that should be 4 millimeters, shouldn't it? Let's try. It should have some overcurrent protection. 6.6 amps. We will find out. It has overcurrent protection. $80 watts? I don't know if it's. Can we get 80 watts over this 240 watts USB-C cable? I don't know. Oh no, this is shit, it has like a male and a female pin. Okay. I have plenty of pins here though. Screw terminals. We should have just a 4 millimeter pin here somewhere. Wait, I will just. Yeah, you can use a banana. Oh, wait a second. Screw terminals. Oh yeah, there might be. Yes, we can try, we can do that. Or I will convert it to ATX. Yeah. I will just use a banana plug here. So this is, which is blue and black. Which one is what? What is plus, what is minus? Does it matter? Black is minus. Okay, so let's go. Assumption. Okay. Okay, black is minus, so let's put minus here. That should be all protected, I guess. I guess so. Let's not destroy anything here. I have no clue. Really? Okay. 12. You know what? We are running it at 900 milliamps. We can current limit it. Here it's everything is fine. We just running it at 2 watts right now. Two watts. You can run it at 2 watts. I guess we won't be able to dissipate. Okay, this is running now in the wrong direction. No, that was the right direction. I think that was the right direction, was it? No. Which direction should it run? It should run in this direction. Yeah, I think we are wrong. No, it's right. No, it's wrong. It should push through the grill side. This side. Okay, we should... Incorrect direction? Oh no, I think that you... Wait. Stop. Stop. Yeah. Okay, reversing wires in. Just to test and then. Okay. Pulse. Yeah, so it was right. Okay, yeah, we can run it both ways. So this pulse. All right. Yeah, no, we reversed it. It was a different way around. But I want it to be the other way around. But we can also rotate the fan so it's more efficient in the other way. So it doesn't matter. We can just reverse it with the polarity, which is quite cool. And I usually wouldn't run it from plus for standard automotive. Yeah, so it's right. That was correct. Also the correct orientation if it's a pulling fan. Now we can try. This power supply is cute, huh? We can try to give it more. Should we give it more voltage? How about 12.3 volts? 14 volts is battery power. 14.3 volts. It's limiting to 2 volts because it's pulling already 900 milliamps. We are current limited. Let me change the current limit. Okay. Six watts. Okay, we will be able to cool this thing. 8 watts. This is running from a U-green brick power supply. watts. I'm scared. It's 20 watts already. Okay, this is max what we can do. Look at that. That came all from this year, but it's not even like it's not even like used all its possible power. I think the limit is like 4 amps or something here. What is the limit? I wasn't able to go higher than. Oh no, 5 amps is max. Okay. Let's try to turn it on again. 45 watts. Woo! That was 45 watts, people. This is good enough for 3 kilowatts of heat dissipation. Okay, that was a good guess. Someone dropped this link in the comments when we are looking for a cooling solution. And thank you very much for that. Whoever it was. Yeah, this is perfect. Yeah! Yeah, especially car radiators. What are they doing? 6 kilowatts? More. Wait. If you have like 100 kilowatt motor and you waste 80% to heat, you dissipate a lot. 80 kilowatts? No. 30%? No. Yeah, the efficiency is 30%. Or okay, like then say 70 kilowatts is just heat that needs to be removed to the radiator. No, it can't be. 70 kilowatts? What? Car radiator is 70 kilowatts? I love this power supply. It didn't even get warm. Oh yeah, you're right. It can get like very hot. Yeah, the delta that we want to achieve is the thing, because if you cool like with 20 degrees air temperature, the delta between, like, if you're trying to keep it at 50 degrees C is way smaller than if you try to keep it at 100 degree or even more. No, it's more, wait, because otherwise the water wouldn't boil if you open like the cooler. Yeah, cool thing. I love it. That's a good solution. I'm not sure if I want to power it from this from the ATX power supply though, because that will induce a lot of noise into our system. So I don't want to take chances here. $100 watt incandescent bulb. Oh wow, alright. That's so cool that you know all the things. Alright, so car radiator came. Did I receive any other things that you didn't see yet? Here. Yeah, I can do that. Like that's so simple with I have plenty of switching MOSFET boards that we can use to regulate that. 0.5 millimeter for $4 of Amazon. 5 watts per meter Kelvin. And we can cut this like in 4 pieces or something. So I need a lot of more of those. I just wanted to test one. And this will be put each of the MCUs have an internal temperature sensor. So we have 65,000 temperature sensors. How about that? So the round heat sinks will be basically what I don't know yet. This is the weird thing. If I mount them on top of that, which will be only this area. So if you can see, we have only like 1 square centimeter of contact area with the cooling fan. Or I put it on the bottom and a lot of vias. I have no vias placed yet. But if I can place it here, I can have a contact area of 4 by 4 centimeters, like this whole area, or like 5 centimeters diameter is the whole heat sink. So I'm not sure. I would really love to have it on this side. Yeah, and this is a thing that I will be able to test once we receive the board. I think I will design this board in that way. Currently, we have this stuff will be always on this side. But we could Hey, Ceboleta Games, what? What? No, I didn't read all the data sheet because it's long, but if you look for cooling rate, there is only cooling rate, wait, cooling rate less, that's just some stats, that's all that you get here. And then thermal, okay, here, oh, we have something, temperature, derating current, temperatures are of the not the converter itself, which is obviously running at higher temperature than blah blah blah. This is from what? There's I think the test setup or something. Yeah, so what they say, thermal protection. It has at least some thermal protection. Ambient temperature. Yeah, you can 20 amps, 70 degrees ambient. What? 70? Okay, so this is that. Where is it? Okay, let me show you their test board. There is like a dev board that they made for testing this thing, which is this one here. Here, these are thermal pads. These here. So this is meant to be okay. They use only what I'm wondering is, do you want? Should we place there more vias than this? You don't know. They don't cool anything. So I will put it on the either on the back or on the front. We have both options because the radiators, the heat sinks that I ordered, they are like even actively cool, like 12 volts fans. Let me show it. Yeah, no, that was right. Here we see this was what the cooling fans that I ordered were basically designed for. Where is it? Can show you. Yes, for like super cheap GPUs. Here, let's take a look. Okay, I think, yeah, wait. This is like a 4x4, and the diagonal is just like the 5 millimeter, 5.5 centimeter. But this is not the sink that I ordered. I ordered this one here, which has basically a round shape. And the pins are at 5.5 centimeters. I might use another angle for the mounting points here, because if we want like a square one, then putting those pins diagonally won't work. So I think I will change that in our design, which is here. Currently, these are the mounting holes, and this is the area for the heatsink. If we put the heatsink on this side, we put it on the, of course, on the case here, which I'm not sure, because this is like vibrating in 800 hertz, and if you have something put on top of that, I don't know if it's good or not, if it's meant like that. But here, yeah, basically I keep this area free of pins. So I want to put it here and have the connectors on that side. Anyways, if I would decide to put the heatsink on this side, then the connectors need to go on the other side, which is all right for the XT60 connectors, but because they're like, you can either solder it from this side or the other side, but not with this 8-pin connector. However, it's all right with the 6-pin connector, and I ordered them as well. So this is like the 6-pin version would be, I think, this side, yes. So we can solder still, if we make those, these two are ground, and I think these two, yeah. And these 3 are VCC or 12 volts. It will work because it's symmetric, it would work from both sides. The only thing that we are missing is the potentiometer and also some resistors and the connector for the fan. And the connector for the fan, JST 2mm connector, can also be soldered off both sides. Oreo cookie heat sinks. Yeah, you know that each heatsink costs still like $4 or €4, and we need 40 of those. Yes, it says thermal pad. That's why I think it will be alright to put it on the bottom. And then we have a clean solution on this side. And yeah, but if it's we want to put it in the enclosed space, so I really want to dissipate the heat on this side. It will also look cool. Yeah. Anyways, definitely heatsink on the bottom, perfect. Because on this board, it's on the top, and they are using this. This is interesting because I had to see that from the close. The product is mounted on a 8 layer. Yes, this is crazy. 8 layer. I won't be able to do that, but because this is you know the pricing for eight layers. We will find out in a second. I read that piece. That's why I will take 4 layers and then try the 2-ounce copper solution. Yeah, that's not happening. That's too expensive. But I think 4-layer 2-ounce option is still all right. The production might take longer. A bolt, yeah. Hey DFJ. 40 of those PCBs. So yeah. All right. So I found like an old graphics card that uses this footprint, this size. So it's actually 3 millimeters holes, and the pins are just put through there. So you just boop, set it through. I don't know if the pins would be long enough to have the 8 millimeters power supply between that, because they are I mean, I could get longer pins or whatever, or take bolts, but if I can avoid it and put the heatsink on the bottom, that would be alright. So this is how I like this design though. If we could get these passive heatsinks, exactly these ones, I would take them. They're black, they're like passive, they're probably good enough for 5 watts heat dissipation, and I wouldn't need like a ton of like whatever active cooling here. It will look crazy with 40 fans. Please find me exactly that one and give me a link if you know how. The FGA, because I want to have a safe thing here. This is optimized. This is safe. I don't want 12 volts to go anywhere near my circuit. It is what it is. It's solved. It's paid. It has been $450 in total for these things. Looking forward to test this. And they're adjustable, so we can trim them. That's what we will do in a second. Okay, let's check out the copper, because I'm curious about that as well. I really would like to do something productive, not talking all the time. If you don't layer to add current capability, you increase the thickness of the copper effectively. Yeah. I don't know how to sign in. Oh, you got that? Damn it, it was cheap. That's cheap. All right. I should have checked that beforehand. Oh no. Thank you, Basil. No, 40 millimeters is all right. Jody found also on AliExpress, which is blocked here, but yeah, I should have looked for 40 millimeters. No, that's perfect, Jody. This is perfect. You found the right ones. I saw them for a fraction of a second. I didn't know what the term was for, but you have also the mounting holes of these are like in the corners. 40 millimeters with the pins. We could also add the mounting holes for the 40 millimeter heat sinks as well. Anyways, let's check 4-layer boards, or let's say no. Yeah, heatsink. Okay. All right, so we have 88 millimeters by 60, and then we have quantity as 40. We can get 50. Oh, all right. Still 45 bucks. That's 45 bucks. Now we have no special lead free. 50 bucks. All right. For that. Okay. We have now heat sinks with fans. It's all right, peeps. I can still think about maybe replacing them if it's too noisy or whatever in the end. Maybe I want black. 72. What if I take purple? 69. I take purple then. And the PCBs will be also purple. That's all right. It takes just longer. What if I take, okay, 2 ounce, 116. Three more days for special purpose. Okay, 116. If I inner layers is also 150. 2 ounce inner layers and outer layers. Metal heat conductor. What? Metal heat conductor? Neodymium magnet? What wagon loads? Is there something that I... Ferrous metal? Okay, it's not like dire. Ah. Okay, I thought there is like an electromagnetic effect which I didn't know of. No thanks. Okay, so even if we, okay, 150 bucks, it's like still 150 bucks. Nothing. In the first place, yeah. All right. So if we want inner layers to also be, if we take 116, wait, if I take, let me take 4 layers instead. 4 layers, 2 ounce. There's even higher ounce options, what? Conductive adhesive now. With lead free. 87 bucks. 2 layer, 4 layer, 49. Ah shit, purple, lead free. Double up the layers, 116. I'm not sure if we even need like the inner layers because they don't do much. It adds a lot of costs, but doesn't add a lot of current. The inner layers. Oh yeah. What if we take a thinner PCB, because the copper will distribute the heat, not the epoxy whatever. Look at that. I have two sides. Maybe we can have. Oh, you think like aluminium? Aluminium. Nah, that's not enough current. Yeah, and also look at that. Okay, I'll show you something. Let's say I want a wire, ground, blah blah blah. Okay, so we can use the tools, Altium tools, to check the properties of this 3mm width, 7 amps. I don't know if you can see that even. But it says it's 7 amps at 3mm. If we make it 10mm, it is 17 amps. It's still not enough. So, and okay, if we do stack up 2 ounce copper, 2 ounce copper, this is half ounce, 2 ounce. Yes, but it's hard. Like you need to take surface mount and XT60 surface mount connectors. I'm not sure if that's. That could be side mounted. Okay, so what is this current now? 17 amps. Wait. The current through traces on. Oh yeah. The length is irrelevant. It's like the bottleneck is relevant, because that's the point that gets the most heat. Like if you have a straight trace, the current rating of this trace, no matter how long it is always the same. It will lose a lot of the power on the way converted to heat. That depends, like the power loss of the trace depends on the length, but not the current rating of the trace. I would need like to load the stack up, but all right. Huh? No. I'm wondering, and I changed it to 2 ounce, but I didn't see any change in current rating for this trace. Let me try again. Oh yeah, now it's changed. 28 amps. So if we have only one side, like we need 10mm trace, that's the absolute maximum rating. After that, it will start to delaminate, most probably. I don't know what it says. Like, this is, yeah. So probably that will just overheat. Yeah. I know, but look at that. Like this trace is as big as this device. So there is not even 1 centimeter or 10 millimeters for this trace. Eh, eh, ah, yeah, oh. Yeah. So this would be able to carry 28 amps. Now let me think about if we have 2 layers ASMR. Right tech channel ASMR. Sorry. Alright, so yeah, we need quite a thick trace with if we have 2 layers. I'm trying to understand if we can conserve some cost. Wait, huh? Where's our MC PCB? What is MC metal core, like alu copper here. Yeah, this is, look at that price. That starts, copper core starts at high thermal conductivity, dissipation, high power supply, and LED applications. Interesting. It's cool. Yeah, that starts at that. If we add some options here. No, there is no options. 1 layer. 1 layer to rule them all. Aluminium is 19. Yeah, that's a little bit cheaper. But I can't use through hole here. Okay, if I go back to that option, I'm wondering if using I still can't use through hole, and the FGA, I just get new problems. I can't use any of my connectors there. The benefit of 4 layers are that we get like plugged vias and so on, but I don't know if I need that. If I take only like 2 layers, make them 2 ounce, hallo nach Österreich, Luca. Ask AI what's the best of a 30 amp regulator in the smallest space. Dip it in liquid nitrogen. All right. Material type. Yeah. Okay. Lead free. Via stick your higher current if you via stick your traces. I'm not sure if the traces, because that's not like the traces are like copper deposition, not like, maybe let me check, via plating conductive adhesive. Yeah, conductive adhesive or not specified. This is like super, oh, it's all not very expensive. Not specified, 87. Via hole. Anyone knows if bigger vias are better or smaller vias are better? Yeah, I know. I will get a lot of vias. The most interesting part is okay. That is something that we'll ask Gemini. What is the best via to get current and heat through 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 PCB? Thermal via array. Why smaller vias are likely less likely to wick solder away from compound, blah blah blah. That's not. Oh yeah, we might need that if we don't use 4-layer. Generally better. Larger total surface area for the heat dissipate copper. Yeah, and also you create like cavities that are filled with epoxy, which is not conductive. At large vias, you could fill them with solder for. Yeah, wagon loads. This only. Yeah, I don't want like to do this for 40 boards. You could choose this option at JLC for kept plugged vias. Heat, you can get them copper powered. Yeah, this is what's the most expensive option. So if we go vias, wait, via covering epoxy filled. No, this is extra plugged. No, this is only 4-layer option. That's like, all right, here copper paste filled and capped, $370. Thank you very much. This is the option. I already checked that. So epoxy filled plugged. It's only plugged. Yeah, we are. I think we will stick with 4-layer boards here. 4-layer with I think 2 ounce. Oh, 114. That hurts. Otherwise, we have. Okay. A 1 millimeter. So it's thinner and can transfer the heat better. 2 ounce plugged epoxy. 72. Tented plugged. Lead free. Anic. Lead free is alright. Oh wait. Gold thickness. Does the micrometers don't help. Yeah, I will just take lead free because that adds like a layer of copper rivets. I could do everything. Everything is just a matter of cost. We can just let them solder through hole components with very thick like pins or whatever. That's a good let's assume we want to transfer like we have 30 amps here in total, which is the absolute maximum rating for this DC to DC device. So, and where it leaves the device is basically this corner here. This is where we get 30 amps. And I want to get it. I don't know. I'm not so proficient with Altium that I would simulate that. Be able to simulate that. Can we simulate it? Tools. Does anyone know Altium that well to simulate that? we can new simulation. No, and it just adds stuff. I guess I have all the options activated. So now, look at. Wait a second. There is even a Samsung logo. Because we getting the good Samsung caps here. Not the Murata caps though, because they were like 10 times more expensive. Okay. So Luca wanted to know how much current. We want to get half of the current over to the other side so we can distribute it evenly between the two layers of 2-ounce copper. Because I think I will stick. Yeah, more or less. Yeah, the schematic, yes. I'm using basically what they recommend. They have like, oh, add more fuses, protection, whatever. But yeah, everything, it's just complexity in that case. There's like no Zener diodes that, like, Zener diodes don't make sense if you have 30 amps output. It's so complicated to solve that, because that Zener would need like to carry more than 30 amps for a short amount of time. Yeah, they recommend the PCB layout, but also their test layout is like 8 layers of 2-ounce per layer PCB, which is like, I don't know, $500 or something. So we're not doing that. Oh yeah, you can check that out. Yeah. So basically, there is like something 8-layer boards. They used an 8-layer boards to transfer the current. But if we look at this, if we take 2-ounce copper, and we will, our traces here, like this trace is 10 millimeters more or less. Yeah, and this one as well, because we need to leave some space for ground as well. So, and we have 2 of those, which are maximum 28 amps times 2 is then okay, Taran. Can I have your recommendation for a Zener? I would add a Zener, even the footprint. Just adding a proper Zener to protect our 3.3 volts, that would be amazing. If you have a recommendation, I take it. This is the time where we add it to the design, because I will send it off before noon tomorrow. TVS, yeah. Okay, TVS might be better, but like the rest of the project. Yeah, we want to protect the rest of the project. It would trigger the overcurrent protection of that. The Zener will go to V out, and that has like an protection. It would turn off, like overcurrent protection. As soon as it gets above 30 amps, it will turn off automatically. And if not, then the device itself is the fuse. The more complicated it is, the less productive are we. Or we are. Are we? Are we? Oi, oi, oi. Okay, that's... I'm still not sure if... Maybe we will take... Wondering if it would be better to have a thinner board, but then... Oh, the FGA. Okay, and then you need like a 30 amps fuse. The minimum will be to have a basic fuse to monitor the current continuously, but it will add some cost. I'm open for suggestions. If you, I mean, we can add like a car fuse or something there. The issue is that we get losses and heat and everything. I just want to avoid that. It will... You can read the data sheet. Output short circuit protection, overcurrent protection. Oh, you can see that. How stupid centered. Input fuse, yes. That's the input side. If it fails, will the output be 0 or 12 volts? I guess they are quite confident that their circuit will never fail, so it will basically manage to do whatever, to manage to do its thing as long it's not like over 12 volts input. I would think that I connect it to, like, the source of the current isn't unknown. We have the Corsair power supply that will never exceed the 12 volts. It's not like a car starter or anything. crowbar circuit, 12 side. Okay, Basil, can you give me an example? That is also what Gemini suggested, a crowbar circuit in that case. Current monitoring. Okay, crowbar. Oops. YouTube shortened the link. Okay, let me search it myself. One second, please. All right. Why did my TTS die, by the way? I can't hear you. Okay, I will put it. I'll put the TTS on Firefox. Yeah, abnormal. Yeah. 9 watts at 30 amps. This is crazy. Adding anything at these currents is just deadly. I would just assume that we have protection already from the ATX power supply. That gives us a clean 12 volts, or it protects everything or whatever. It's not like an then so we have like the power supply here. This is good. This costs hundreds of bucks. It has probably a fuse. Does it have a fuse? I don't know. Maybe it has a fuse. So it gives us clean 12 volts. And then we bought a quality product, Murata. 1 milliohm would be fine. And then it probably has a self-resetting fuse. Yeah. Then if it fails and we have like this thing gives 12 volts, it kills four PCBs. Might kill 4 PCBs. I don't know. It might just like it might I don't know what happens in that case. In the worst case it will. ATX power output kill signal. SPI lines. Good point. That might. I'm wondering if the 12, like we are below 10 milliamps per MCU. So if we have 12 volts and distribute over 4 PCBs, that's 2000 MCUs. Like it must be a lot of current to destroy any circuit there. I don't know. Hall current monitor. Yeah, I don't know. If it fails and everything burns and it will be just content and there will be pity and there is always a good thing. If something breaks, there is always a good thing. Allegro, current. Yeah, we have current probes here. Where's my current probe? I have like those, a Hall effect current probe. Let me show it here. But I won't install 40 of those. What are you talking about? I have a few of those. Where is it? I don't know. It is somewhere here in this huge mess of. Maybe here. Kelvin traces. What are Kelvin traces? What is that? Kelvin traces? What is that? Huh? What is that? Please elaborate. I won't be able to read now for ages here. Kelvin connection MOSFET. Huh. Oh, all right. Long sense. Yeah, there will be 30 centimeters maybe. Okay, let me check. You mean it's probably yeah, I was wondering as well because they have oh, interesting. Let me check. They use I think it's a 0 ohm resistor here. Application circuit for evaluation board. They have like an extra sense. Oh, that's what you're talking about. Look at that. They have something on that. Shielded by the ground line. Okay. Something has reduced noise pickup. The sense line. Yeah, but what it will do, it will output like 4 volts. But I don't mind a voltage drop. I don't want like it they we are running at these voltage that will be stable for it. It might even go down to 2 volts. So I don't mind to calibrate it. Within 10 centimeters, yeah, that's not happening. But we will take this. We will add a footprint JST footprint for that sensing lines. Maybe, or maybe we will use these lines here for sensing. Right. Okay, let's finish it. Yeah, that's fine. I mean, I don't want to throw away if that project fails or whatever. If I disassemble the device at some point, I still have like this is quite valuable stuff. I still probably want to use those DC to DC converters later. Sense line if the regulator doesn't fail. Yeah. I guess you could add endless protection there, but the FGA, please design your own circuit. Why? Because it's 30 amps? I'm still not sure if we get away with 2-layer board that's thinner just for the thermals. Now I'm also lost. I don't know where the window is with right. Yeah, so SMD banana connectors, really? Yeah. But also I want it like if I bump it or whatever, SMD is always fragile. It's only as good as the soda. Okay, so um, I think we will continue just with the design right now. Finish that for today. Then this was the plan anyway. So the test board that I got for my blade here is already on the way to me. Look at that. You devices with legs, yes. Look at that. A shipment tracking. This is oh con. Ah. All right, here we go. Yeah, it already. Oh, what? The test board's already for the blade. I have like a test board where this can plug in, only one, and I have all the. Yeah, let me show that in Altium here. Do I have the test board here? No, it's not here. Open it. Where is it? Blade 8. Power board. Can't find it. It's gone. This is it. There. Yeah, it's always like that. We could just end like it doesn't scale well. Having that protection, I don't know. If it is like if it was like a space probe, I would certainly add some protection. It isn't. If it burns, it's entertainment. It's another kind of value in the end. That's how I measure things here. And the best things, you have a I told you moment at some point if it breaks. But dev board here, this is what this will arrive before I even get. I designed it later. Hey ITT, are you going? A resettable fuse. You. Okay, so you can. This is the test board. It will arrive tomorrow. So actually, I'm able to basically test everything, and I have like the different powers here, and I will test it with this device. Yeah, you're you're right. We could use we can make it a tank, or we make it a ship, a starship. Oh, what are those pins? Okay. Forget it. Forget those pins, but these test boards will arrive tomorrow. Okay, I can also close this project. And then I will be able to test that with all my tools. What? No, I didn't say it's end of the stream. Until the end of the stream, I will let's just finish this or complete the circuit, the reference circuit here. This it's so weird. Okay, yeah, that's the added protection here. They want the fuse and the diode here and the joggled to be in line. Shows the output. Wait. which page? Trying to find it as well. There is like, okay, these are the lines. Now we'll stream for another hour. Yeah, also, yeah, I'm not selling it. We will test it with a load and everything. Midline, wait, what? Okay, V out, sense, V in, these are the caps. They just want, I guess what they are trying to do here. I don't know what you're referring. What's the input plus? Symmetry is the answer. Yeah, that's what I'm wondering as well. Why did they do this like that? I guess they want the caps to be close to ground and input, but that doesn't make any sense if you have like this bottleneck here. I guess we can make it like a complete topic of a video, whatever, to make the power supply perfectly good. We can go like for this project, it will be perfectly fine if we just trust this thing and do whatever they require on the outside to make it. Could it be to negate magnetic flux? Oh, of that. But if it's like completely, like I would expect the flux to be contained within the shell, this ferrite shell. Where did I drop it? I lost my buck converter. No! 14 bucks gone. Yeah, I would just roll with my chair over that piece. Eh? What is this? Yeah, we need like the same current path. Oh, here it is. 50 bucks. No, it's 14, and I got them quite cheap. Now it's here. I found it. So if we look at the traces, that's why I could go like that, but then I'm basically the ground needs to be as wide as that. I have a shelved tools here. So this is my ground. Oh, the ground has a higher priority on the floor. Yeah, let me change that. G and D needs to be low. Okay. Inner layer. Okay, priorities. Okay, so this is how I did it, because we need like a ground path, and the ground path is interesting. It has to come from both sides. If I use this connector as input, we need a lot of, like, this will be the bottleneck probably. I mean, input, I don't know if we could make it like shift deadline here. Come on. Let me turn off the properties, polygons. No, wait, I need the polygons. That's why I don't like this. Shoot. I shelved it. Okay. This one, okay. So if I move it like that, I could do it as well, but I don't see much more. Oh no, I need that space for the caps. Wait, let me import the design changes. I also have, I think I might need like this. These are the input caps. So I need them to be here. Okay, this is the space for the input caps. I will probably also add more caps on the output, so we have basically spare ones that we don't. Now, finally, we can do some design work here. I will add more caps that we don't populate in the end. So we use that. That will be 11, 12, 12, and then we do type. Oh, standard mechanical graphical. No. I think we do that. Go to this here. Import the changes. Oh, there might be even like, oh, there are still designators. I hate that. I didn't find a way to turn off designators for like when you import them. But I can deactivate all the designators at once, like that. Okay, so we have an extra cap, and then I will put those here as a type. No, wait, there was one setting where you can exclude it from BOM. Was it type? Or no? Oh, standard no BOM. Yeah, that's that. So it will be excluded from BOM. It's like do not populate, I believe, if I'm not wrong. Can I do that here as well? Standard. Oh yeah, standard no BOM. Here we go. Standard no BOM. All right, so we have some extra things, and then I will add maybe also 2 more on the input side if we need like to do whatever. So let's put it more there. We were at 12, 13, 14. Oops. Just so to have some slack, and this will be also standard no BOM. Let's get this also in here. Oh wait, we don't have the space. You know what? Then I will just use 1. This is how you do design decisions. Doesn't fit. I'm too lazy to change. And let's do it like that. Close, all right. Uh-oh. Ah! It's touching! It's not touching if I get this polygon and then move it just one caret up like that. Boop. And you know what? Did I copy it multiple times? Oh, damn it. Yeah, it's on each of the layers. I really need to think about if I want to pay. GA. Oh. Come on. There's still on one of the layers. I will shelve this thing here. Polygons. Or can I lock it? Oh, you mean like it should be... Yes, we can do that. That's a suggestion that I take. 3.01 and tilt it slightly. $22.49. So it's exactly how it's supposed to be. Wait. Oh, come on. I want, yeah, let me check if I can I lock this somehow? It's so annoying that I always, when I click, it's always being selected. I just want, like in KiCad, you have the possibility to lock it. Yeah, you know what? F this, I will shelve it, and then we are done. Here. That's shelving polygons is the best. Here. Is there another All right. We don't need to shelve that one, I believe. Doesn't annoy us. Does it annoy us? No. Yeah, so basically they try to get these caps closer. We could move it like that, but I don't see... Yeah, it's all right. It will be fine. We can populate those four and those four, which are more or less there. They're just overcautious here. Wait, why is this much closer than these here? I could use a different footprint for those. Wait, is this a bigger one? Yeah, these are bigger. Yeah, just leave it. Bigger footprints. Anyways, these are those caps. Oh yeah, what I wanted to do is now I see what the issue is. Text. Okay. Input caps. You mean like here, like that? Yeah, that is not bad. You know what? Now we can add the other cap again. Control and Z. So we have the option also to have like 2 extra caps here. Like that. Alright, I like that. Okay. So these have been the caps. Now we need closer. No. I want, like, I don't want it to be difficult to work with that. This is physically. Oh, you mean like here? No. I'm making the PCBs. We will have. No. I have all the DC converters here. I needed to source them from different sources because yeah, it's hard to get them for a good price. I think the LCSC has them even. It might have them, but I got them like even like few euros cheaper, and I didn't know if how I want to assemble it in the end, because we might use different connector, whatever. So I mean, I just don't want to pay 200 bucks for putting this thing on and a few caps, and then I have to sort out the connectors myself anyways. I will just get the boards, get them quicker so I can test it, assemble it. If something goes wrong, I didn't pay like hundreds of bucks for something that I can't reuse. Heatsink is going on the back, and that's why I try to decide if I. And time consuming, that's like the time factor that it took them to review. It's like adding another week, and this is something like that gets out of our control, and I want to keep it under my control here. We are still missing the input electrolytic cap. This is a bigger one. Wait, where is which? Murata chose the caps for us. Here we go, Darren. No, it's the heatsink is it's a circle, and we can, with the distance of the hose is like fixed 5.5 centimeters. Okay, yeah, we need where is it? Bye, Jordy. C1, they want like this C1 That's optional here. And I'm worried if we have like electrolytic 1000 microfarad electrolytic caps. I ordered them. We have the option. If we add them, that we will get like we overload our ATX power supply. Because if we have 40 of those, that's 40 millifarads. How much current will they draw? I will add the footprint for C1, but not really. Yeah, I will not place them most probably. I just need to keep them also. Yeah, but these are never like 1000 millifarads. Microfarads, sorry. It's like quite a lot of. I mean, I can take another size, another value for that. Where is it? Okay, here is my parts list that I got. All right. Good night, Caspar. So this is. Oh no, I don't have a data sheet for those. I just got some cheap ass whatevers. SMD D10. Okay. Set 50 millifarad? Alright, okay. Yeah, 12 volts. I guess, I mean, the ATX power supply will do the job. It's just if the I should have that. It's just if just need some maybe good. What did we determine is the best via size for thermals? So, oh wait, was it Gemini that we? No, what was the? Someone was it? Okay, here we go. As many, yeah. I will take anything that doesn't add extra cost and time. 0.2, 0.3. Yeah, that's all right. Perfect. I think this is why I kept this one here, because this via here 0.25 is hole size, diameter 4. Yeah, this is the vias that we get like basically for no extra cost. So we can place a lot of these vias here anywhere. DC fan. Yeah, I will probably use a different power supply for the DC fan. I know that this is something that I don't want there, really. We will check that with the oscilloscope, what the actual noise is that the DC fan creates. If it's alright, then we will keep it. Otherwise, I will just add a separate power supply from mains for that. Maybe good, and there's only one VI. All right. Elec cap. Yeah, let me add that one. More power noise. Yeah, we will test that. I can get some fan control. We can even like I have like the controller boards for MOSFET boards. We will be able to control basically the temperature. Hexagonal packing. Ooh, fancy. Yeah. But they have like a distance, a minimal distance. You can put them in square. Doesn't really matter, believe. Yeah, no. Yeah, you're right. We could put them oh. I guess it's everything is just overkill right now. Okay. First what I do is let's get electrolytic cap. Yeah, I know. We want okay, connectors, passive components. Okay, why do I get yeah, okay, here we go. I want filters. All right, yeah, this is what I want. Wait. Dielectric. What is no? I want. Why does it start at 1 farad? I want. You want me for this project to go like for 10 more years, huh? Millifarads, so basic. That's millifarad. Here we go. Doesn't work. Wait, what? What is this crap here? Show more filters. Aluminium. There is a reason why I split the power supply into multiple boards. There is one thing interesting, maybe here. There is even a use case here. We have right here. There is like this input on off switch, and there is a power good switch, power good output, and you can daisy chain them. Basically, either you can daisy chain them or you can control it from the microcontroller, basically to turn on one after another. So I can ramp up the power. That's not like about the fan right now, but this is something that I'm also considering, just not to like switch on 800 amps at the same time. I will just have a sequence either automatically by daisy chaining them, so one after another will ramp up, power sequencing, or I will use like one microcontroller that does the thing, both on and off. Oh, for turning it off as well. Yeah. Yeah. Oh, yeah. Turning off can have a voltage spike, doesn't it? Yeah. With all the inductors discharging. Load dump. Yeah. Yeah. Evil inductors. Huh? Okay. So now I get some proper filter. Still, why is it so? What is this here? From 0. I don't know. This is somehow useless. Okay. Wait. I have maybe the dimensions. Where's my part? Where's my part here? Aluminium can. Oh, really? That's why there is a sequence how you connect. Like if you jump start your car, you have to connect it in the right way. Otherwise, it will kill it. What is D and what is L? Diameter and then length. DL. Okay, D10, 10.2. Let's just find something that's similar. Microfarads, 100. They don't. Oh yeah, dimensions. Length. Was it 10? Oh, whoa. Okay, what do we have? Where's my filters? I'm just trying to find a similar ESR impedance ripple current. Wow. This filter is somehow useless. I can't use it. From to. Doesn't work. 0 to. What do you want? What's the problem? I believe it doesn't accept. Yeah, it says comma because that's like, oh, this is so stupid. From to. Why do you start like minimum? Ah, right, okay. No, I just want these. Here we go. Now the filter works. 10 by 10,000 microfarad. That's what we were looking for. But there is no part designed for that. Damn it. Wait, we can remove our maybe that's a market gap. We can manufacture zero farad capacitors. Oh, why this filter close? I don't want to close that filter. Okay. Ceramic height. The height is smaller, huh? Was it 10 millimeters? I believe. Yeah, that doesn't work. Yeah, I need more options. This one isn't designed. I don't have that footprint. I'm stuck here. You know what? That could be quite some challenge to make that, because 0 ohms is 0 farads is basically, there is always some kind of charge, isn't it? Like, you need to go to cool down to absolute 0 Kelvin, or there is probably no charge in the center, like singularity or something. But there, otherwise there will be always a how do I get? I want a footprint for. Oh, you know what? We can create the footprint. That's easy. All right, let's try to get a footprint for that little thing that we saw earlier. Height 10 millimeters. Let's take this one here. Let's store it. Capacitors. Let's just create it. Whatever. Okay. Symbol wizard. It's just no. Okay. Let's see. We can chip here. There it is. This is how we work here. Now, I don't have the specs for this one though, but okay. Height is 10.2, so we have the height. See, that is 10.2. Then we have diameter is 10. Body width. diameter with diagram. Let me check. Yeah, it's basically also 1 by 1 millimeters. Oh, that's lead span. Body length is basically 10. That's the cap. And now I want the leads. I take the footprint that they are showing, which is two milliliters. Hello, Pishan. I think it's 1.8 what they use. 1.8. Wait, this is oh, that's the lead. That's for 5.2 or something. 5.2. 5.2. That's what they. No, it's not. How can I work if there is no. Oh, wait. I have the part number here. I should have used the manufacturer part number. Can I get the datasheet for that? Okay, let's do 11 then. Body length range. Looks like it's 11, it's slightly bigger than that. And we have 1 millimeter in width. TV is like 1. And inner. We are still building 6. Sorry, let me concentrate for a second. T is 1.8. I guess this the ultra cluster. No, wait, this can't be. Oh yeah, that's double that. Basically that will be 3 millimeters. 3.2, more like 4, I guess. Yeah, let's leave it like that. Finish that. That's our footprint now. Let's take a look how it. This is. Extruded is weird, huh? We can change the color, override it. Huh? Yeah. This color has more aluminum. Here we go. This is our capacitor. All right. Now we need to load the symbol. Isn't there like capacitor? No, there is no. Discard the changes. I will use. No. Painful to watch, huh? Existing. Wait, capacitors. Capacitors. Let's just look for switch transistor. Oh, bye-bye, Terran. Thank you for your constructive contribution. Oh, wait. Do we have an electrolytic capacitor somewhere here? I really don't want to draw. This is like weird. Oh, here we go. Cap P. What does that mean, cap P here? Yeah, let's just now I need to be sure that plus is 1. Yeah, plus is 1. That's correct. Okay. Let's save it. Store to the server. Okay. That's our electrolytic cap, and now we can physically verify if it's actually fitting where we like it to be. Alright, so Explorer. We just filter it like generic folders. Find it. This is my new one, huh? Yeah. Bloop! Such a little tiny symbol. Boop boop. Oh. Weird. Oop. Here we go. The one here. Okay, I guess I can. What was that on the data sheet? Data sheet was. I think it was. C. 20 no. C21, what was that? C21. Oh, I will just call it the same here, even though some others are not called the same way. Oh, it's so weird that it looks so different here. Yeah, C21. And then we will do a no place, also standard, no bomb. Here we go. Okay, so okay, our oh shit, this is a huge cap. What? This is massive. Where do I put that? You're in bed. What? How do I? Where do I place this cap like that? Here. Oh shit. No. Yeah, I have the angle is set so small, the rotational angle, because I used that for the other PCB. Here. This is where I place it. Yeah, I'm not sure if I really like it. What's with my polar grid? Let me show that again. Polar grid is going here. What is with that? Why is that so marked? Ah, yeah. Okay, so polar grid, yo. This is gross. Or I use a 6-pin connector here. Oh. That sounds that sounds like a good problem to have. Yeah, there's no way we can fit that there. This input cap, it's surface mount. Ah, shoot. We can get this connector as close as this one as well, but now we are stretching. This might not even fit in between. Oh, what? Tixo Geek. That's a coincidence. Because we are making a CH570 project here with 65,000 MCUs, and apparently we need a lot of current, and this is one of the 40 power supplies that's converting. Each of those is converting 12 to 3.3 volts, 30 amps, but we will only drive it up to 20 amps each. So yeah, this cap won't fit very well. It's optional. Yeah, wow, that's so tight in there. Yeah, I don't want to do it vertical because the current, the negative current still needs to go here. If I put it vertical, then it needs to go around. I want to keep it like that. This is already quite sketchy. Yeah, I can't place it there. I might just not put it anywhere. Or I shift everything downwards a little bit, but then it's not symmetrical anymore. So the decision is beauty or function. No, function first. Ah. Why is this so big? Why did I buy such a big cap? I mean, it's 1,000 microfarads. It's full of compromises. We don't really need it, and we are shifting the connectors around that are carrying all the current. Okay, you know what? We can leave it like that. This is at the limit. That's why I put the circle here. So I know that we can put like a standoff or a bolt in there, a 3mm bolt. Same here. We have slightly some space next to the XT60 connector, but if we want to plug something in and there is a standoff right next to it, might be like really sketchy. Also, we are quite, yeah, that's ground anyways. All right. We could move it slightly like that. And then move the cap over here. Yeah, let's do it like that. And then we can change that like that. Boop. Uh-oh. Yeah, that doesn't work really. Wait, how do I do it? It's my reference here. Let's go to the top layer. Yeah, that works as well. That's weird with this fat ground pad here. All right. I guess we can live with that. But we can move this one over here. That works. Ground, Vin. We can move a little bit over. Come on. Why doesn't it snap? It wants me to snap. Oh, the polar grid. Yeah, I need to turn it off. It snaps to the polar here, known component here. Yeah. Okay. Yeah, now it's good. All right, this is perfect. We could since this is not like functional at all here, this corner, we can just cut it off. Yeah, we need the ground to be transported here. So the ground is currently, okay, this ground is going this way anyways, but this will be good. Maybe I need even to rather do it like that, because this ground here, there are holes and everything, needs to go around this corner. Alright, so let's do it like that. Beautify. Now we can shift the corner slightly. Let's leave it like that. We might even want to put, vias, we will put them all here. Okay. So, you know what, I will remove all the other ones. I can just copy them later. Where's this? This is the shell of it. So like, okay. Almost looks like a design here. Here, this corner still annoys me. Right, so I won't place arcs. I could place arcs, but I really don't want to. So please don't request that. I'm talking to myself anyways. Here. That's it. Let's measure the diameter here. 11 millimeters, that's alright. So we can carry like with 2 ounce, that will be already enough current. I probably want to keep the thick PCB. Not sure if I want like the 4-layer design still. Might be, yeah, distributing the heat like with the 4-layer. It's I think the cost difference was $30, so it's not very substantial. I have to sleep over that anyways, but that's the new design. By the way, we can place, instead of this one here, we can place, I might indicate that. Top overlay. We might be able to use a 3-pin connector instead, because this is like only the 4-pin version, and this is ground. This is ground. This is Win. In the end, I won't even use that. ATX probably needs something on the sensing wires, do they? I need to check that what we need to put there, because there's like sense 0 and sense 1 for some purposes. Alright, so this is be in. Null point of the yeah. Alright, and this should be, maybe we should also, yeah, there is also a plus here already. Okay, this is important, plus plus, this is important. Let's take a look how it looks. Oh, nice, nice. If we need a fat cap, we can place it. Otherwise, we don't need it. F this. This will be cool. We need some vias. Let's see if we can place the... Oh, yeah. I need to re-enable the ground, maybe. What's the setting? That was 2.4.5, 2.5. Okay. 0.45, 0.25. Okay. So these are the pads. I'm not sure if I want to. Oh, if we use 2 layer boards, we can get, oh no, we will otherwise have, what? What do you mean? That's perfectly fine. JC will kill me for those. Yes. Why is it? What is happening here? Do I have still like some grid going on? All layers. Let me do grids, guide access, currently off. Okay, oh, it's good. Oh, I missed that. Okay, unshelf the polygons. Unshelf restore. All right, TGA, and then we can place them. Thank you for joining the stream. You too. Bye bye. Tixel Geek. Oh shit. That was wrong. Okay. Brr, 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 brr. The poor drill. I'm a carbide drill, but still. Dude, what are you doing to me? I'm drilling through 5 boards at the same time. Ah! I just continue this grid here. Yeah, I will not do that. Okay, here we go. I might be, yeah, I might need to do more than that. Oops. Ah! Don't need components. I want only bop 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 bop. How about, oh, this will might drain our pads. Not if I do 4-layer boards. I think I will do 4-layer boards and then just let them cap that. Okay, that's plenty for ground. Now we need something for non-ground. All in. Oh no. Oh no. Oh, okay. Pips, I need to shelf a polygon, I think. More current on the output though. Okay, so I need to shelf. Here we go. This is the high current output. Do you think that's enough with the vias? Here, maybe more on this one. That's a lot of vias. We need to charge you more. Yeah, I think this is plenty. I guess this will be alright. Woohoo! A lot of vias. Here we go. Now we need some, still some, yeah, it's good. I might need the connectors though for some JST and so on. But I think at this point I am ready to say good night for today. We need still to adjust to the new times. Oh, it's 12 o'clock anyways. All right, peeps. Thank you. It was like heated discussions today. I like it because I need to be challenged sometimes. Yeah, ITT. Thank you for joining and also for participating. There's good things that come from challenging me. The good thing is we will use XT60 connectors most of the time. It looks like like power electronics, the RC people basically figured it out. It's the cheapest alternative because they are so widely available. Also, the cables aren't as expensive as PC cables. It might look like, all right, getting another PCI Express cable that whatever does like a Y cable costs only $5. But if you have to do that 40 times, that's already more than only $5. So that's what I learned from being challenged, or at least that was a suggestion to use disconnectors, and we learned, and here they are here to stay. That is just one basic example. And I will think about what was challenged today: sensing wires and whatnot, protection, if I want to have a fuse or not. There is always a way to put a fuse in between whatever, but between the power lines that coming in, I don't need to have everything on my board here, but putting something in between here, like with the high current path, I mean, that fuse will be alright, but a Zener, anything here is really challenging because this is high current and any resistance here is a huge power loss. So that's that. I like how it looks like. Maybe I will replace the text. But tomorrow I will receive the first post, and next time, on next stream, we will have the blades here. I hope they will work and we can try to write some code, because we need to reprogram them one by one, the MCUs. So actually I want to do it once, and then using like an old 3D printer we can repurpose the Prusa printer, because that doesn't print anymore, but it's still an XYZ machine that we can just put on the pogo pin on that to program everything. And then we need to figure out a code for basically re-uploading over SPI, something like new firmware, loading stuff into SRAM and running from SRAM, stuff like that. So a lot of, I hope we can have, like, we can finish the hardware work or design work quite soon, and then continue with the good part, like coding and trying to resolve all the issues via code. All right, thank you everyone, have a good one. See you next time, bye bye, and have a good Easter if you celebrate Easter holidays. Yeah, I wish you to find many eggs. Best of luck. Probably sleeping, but bye bye. Yeah, have a nice Easter holidays. See you next Wednesday, hopefully with the blades. Yes.